All right, we're going to look now at using substitution when you're working with definite integrals. Definite integrals, we have to think about now the fact that we have these limits of integration to deal with when we're making changes to variables involved in our integral. So you can tell just with this integral here, we have a function inside of another function. We have a composite function there. And you can tell that substitution is going to work because this one inside here, its derivative is also present there. It's multiplied by its derivative. Now, not its derivative is 2x, but there's an x there, which means substitution is going to work here. So if I let u equal x squared minus 1, then du is going to equal 2x dx. Now, I don't have 2x dx, I just have x dx there. So I'm going to slightly change this around to a half du is x dx, and then make that change. So I can make that into du. I'm going to put the half right out in front of the whole thing. Alright? Just so that I can leave it till the end. And then I'm going to make this change here, x squared minus 1. We said that that was going to be u. So we have u to the fourth. Now, we can't just put integral from 1 to 3 here. This is the big thing to realize here. These are values of x, not values of u. So if you write this, this is an incorrect thing to write because now these are not the correct boundaries. When you make a change to this, you're going to have to make a change to the boundaries of integration. Essentially what you're doing when you're making this replacement is you're writing an equivalent integral using a different simplified function. And if you don't get those boundaries to match the variable that's there, then it's not going to be equivalent. Alright, so we can't use 1 and 3 there because they're x values. What we are going to do instead is figure out what the corresponding u values are. So we're going to look down here at if we want to know what u at 1 is, right? Because that's our lower limit. The u value for 1 is 1 squared minus 1. I'm just using this, which we started the whole thing with, so that's 0, of course. And then we want to know what u at 3 is up here. Well, it's 3 squared minus 1, which is 8. Alright, so we're going to put that in. We're going to go from 0 to 8. Then we can work this out. We have a half, and we're going to work out, we're going to use an antiderivative here. 1/5 u to the 5th from 0 to 8. So we need to know now what that's equal to. I'm going to probably run out of room here, so I'm going to move this out of the way. I'm going to put it over here. We're going to have 1/2 of 1/5 8 to the 5 minus 1/5 of 0 to the 5, which of course that second part is just 0, so we got 1/2 8 to the 5th. Now I know some powers off the top of my head, but I don't know what 8 to the 5th is, so I'm going to quickly do that here. 8 to the 5th. And actually we got times a half, so I'm going to divide that by 2. And so we're going to have, what did we have there? 16,384, I believe. 16,384 over 5. Right, because this is 0. That's going to disappear. Or, of course, we could have that as a decimal if you'd rather have that, divided by 5. 3276.8. 3276.8. Now, before we're finished here, we're going to look at this graphically. Number 1, to check our answer, and number 2, to get a better sense of what's going on here and why we have to change these boundaries of integration when we're using substitution with definite integrals here. So if we go to a graph, now we're going to have to put our two functions in. Let's move this up. Our first function, we're just going to put in x and x squared minus 1 to the power of 4. Okay, that is going to be in there as f. We're going to put our second function in here, y equals, now we got to put the 1/2 in. I'm going to put 0.5. Even though I wrote that outside of the integral, that's part of the function, x to the power of 4, once we made that substitution. Alright, so there's that function. Now we're going to have to change our boundaries quite a bit to see these. Maybe first of all, let's change the colors of those things, both those functions. All right. And let's change the dimensions of the graph here because those get pretty steep pretty quickly. And we're going to need to see them. The red one, we were looking at the area from 0 to 8, right? Once we made the substitution, those were our boundaries, 0 to 8, so I'm going to go from there to there. The original one was boundaries from 1 to 3. Now, as I change this, what you're doing graphically, if you want to think about this graphically, when you make a substitution, you're using a different function, but you're setting it up so it has the same area here. So this function, the blue one, f, our original one, what we were looking for was the area from 1 to 3 underneath that curve. So we were looking at the integral from 1 to 3. If we're doing it graphically, it's just as easy to use either one if you're using software like this. If you're doing it analytically, it's much easier to make that change and work with an equivalent function and look at the area. So this is going to be the same area. The area from 1 to 3 here is going to be the same as the area underneath the red curve from 0 to 8. All right, now just to show you that, let's put this in here. Integral f(1, 3). So there's the area under that. That's that number we came up with. And when you make that change to u, you're using a much simpler function to work with analytically, but making changes so that the area is the same. So if we are looking at integral of g, we want to go from 0 to 8, not 0.8. Let's fix that. 0 to 8. That area is exactly the same. So using substitution with definite integrals, you have to change those boundaries so that you keep that value the same, right? Those have the same value even though you're using a different function. All right? So that's evaluating a definite integral when you're using substitution. And the key being, again, that you got to change these boundaries of integration, those upper and lower limits of integration, to match the variable that you're using. All right?